Hey everybody, this is Larry. This is day 8 of the January Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Oops. Uh, Check if two strings away are equivalent. Generally I do these live, given both looking at the poem for the first time and explanation. So definitely let me know what you think. If it goes a little bit slow, feel free to fast forward. So this one should be seems pretty straightforward because there's a straightforward linear solution for it. I don't remember whether I this feels familiar in that I think I did this during a contest, maybe recently, maybe not. But basically the how I did it, how I think I would have done it during a contest is I just would have done something like I joined the word one, and then I checked whether that's joined word two, right? And if I had done that during the contest, I would submit it, and I would get it in about 20, 30 seconds, maybe a minute, because I have to open the form and stuff like that. And that's how you would see me solve it in real time in a contest setting. So why wouldn't we do this then, right? Well, this goes through the array and create a new string which is linear, and this takes linear space on both the size of the input, which is roughly speaking n plus m, where n is the number of characters in word one and m is the number of characters in word two. Though they should be linear in terms of complexity, because we're doing, let's join. I believe joined probably should be doing this in a not stupid way. And in a more naive way, you may think you may do this explicitly, which means that you might do something like, for word in word one, we have a concat one is equal to empty string. We have concat one, we concat the word into it, and so forth, right? This actually is slower than the join function because every time you concat, it creates a new string. So then in a way, it actually becomes n square, which is not what you want, right? But in either case, so this will be n square space and probably even n square time. So actually this is pretty good relatively, but obviously if you're solving it at home and you want to practice, we want to practice a constant space solution. And the constant space solution is just doing it manually. Look, just having a pointer to word one and a pointer to word two, and then go for character by character. And obviously the characters are, the 2 pointers for each word, the word counter, and then a pointer to show where in that string it is, right? So it's just a lot of what I call bookkeeping, which is just keeping track of things. And yeah, and I don't think there's anything that tricky with respect to edge cases. That's my thought. And yeah, let's play around with this then. Index or just trying to think about naming things is always hard for me. But yeah, W index 1, meaning word index, is equal to 0. Character index 1 is also 0, say. And then we set that for word 2 as well. And then while what is the end condition, right? I want to say it's something like this. But I don't think, I think I wanted to do it character by character in a way. So this may not actually be the invariant or condition that I want to do. But let's kind of see where it goes. This actually is a little bit annoying. But it's just it actually reminds me a lot of a linked list problem where you have to keep track of pointers. So if you do have trouble with like the invariant stuff like that, just take out pen and paper or pencil and paper and draw it out. I think that's where having good visualization for these problems will help you in the future. And when you see someone who is practiced, and they're able to kind of, you see that they're able to keep them in their head, A lot of it is because they've done it before many times, and they kind of be able to visualize it in a more intuitive way. But that doesn't mean that you should be in the beginning if you're a beginner. And if you're watching this video to this point, you're probably a beginner, or and that's okay. Or you're just excited to see me, which I'm happy to about as well. So yeah, I don't think this is accurate if we want to do it by character. So then yeah, if word one of index of one of C index one is not equal to word two of this thing, then we return false, right? And of course, we have to do something with respect to getting this as well. So, so we definitely want to do something like C index 1, increment 1, C index 2, increment 1. We have to check that if C index 1 is equal to the length of word 1 of index 1, then we set it, we set it to 0, and we increment this by 1. If C index 2 is index of 2, C index 2 is equal to 0, index 2 plus 1. So I think this should be okay, actually. So I think this precondition only happens, or like this, we only get out of the loop with one of them where it goes toward the goes past the end of the word list, and in that case, you want to terminate anyway because there's no characters to eliminate. So then at the very end, we just have to check. I mean, you can also combine these statements, but for purpose of these videos, I just make it explicit, which means that if Windex is not equal to the length of word 1, or Windex 2 is not equal to the length of word 2, and what this is saying is if one of the pointers are not to the end, because they both have to be at the end at the same time, then we return false, otherwise return true. Alright. I really do think I solved this problem in a contest before, so I'll put a link to that explanation. I think it's I mean, I think this explanation is probably going to be better, but you could watch me during a contest, and so so that would be pretty good. Or like maybe interesting, I don't know. If not, you don't have to. Okay, so that looks good, just to kind of run it real quick. And now we'll give it a submit. And hopefully that's good. Yep. And again, what is the complexity of this? Of course, we only have 4 pointers, 2 for each array. So that's going to be constant space. And of course, we look at each character at most once. So it's going to be linear time, the size of the input. That's what I have for this problem. Let me know what you think, and I will see you all tomorrow. Bye-bye.